Yeah, good evening all and welcome again. So we are discussing on the cable model, cable selection and the sizing calculation. So yesterday, let us quickly review what we discussed yesterday. Yesterday we started this topic. So what we discussed about the cable. So we started what is the available electricity transportation medium, and then in that we discussed there are two medium available, that we can use the overhead transmission line or we can use the underground cable to transmit the electrical power from one place to another place. So we have discussed that a comparison between the overhead line and the underground cable. In that we have discussed about the comparison, and after the comparison we discuss about the charging current, that what is the concept of the charging current and why this charging current is coming in the transmission line and in the cables, and why the charging current in the cable is approximately 10 times higher than the equivalent same length transmission line. So that we discussed yesterday, and then we discussed that the same charging current also indicated in the cable data sheet. So when we review the cable data sheet and when this terms is coming, so whether we are familiar now or not, like the cable charging current, then what is the meaning of this? What stand for this cable charging current? So after that, we discussed that uh, we have taken an extract of the SLD, a snapshot of the SLD. And in that, we discuss if we have some equipment indoor and some equipment outdoor, and we need to interconnect both equipment. In that case, we require the cables. So, when we are preparing the SLD, so at that moment also we have to indicate the cable type and then cable size. So we discussed that what is the overall responsibility as a design engineer regarding the cable. So we should know about the cable selections. We should know about the cable sizing calculations. Then datasheet preparations or datasheet review of the cable supply, and then cable installation drawing preparation. So this all like tasks we have to do regarding the cable. So we started first about the cable selections. So this is a snapshot of the cable data sheet that we have taken. So we discussed that in order to prepare or to review any data sheet, we should know about the cable construction internal parts. So we started with the cable construction internal parts, and in that we discussed that cable must have three minimum part, like conductor insulation and outer insulation or outer cover, but these part will increase based on the applied voltage, based on the site conditions, and based on the project technical requirement, any specific requirement. So after that we have taken a comprehensive overall part about the cable constructions. So here we have seen that cable have the inside core or conductor. So after the conductor, the cable have the conductor screening. So we discuss that where the conductor screening we have to take and where we have not to take. So these are part is important because you have to do the selection of this part, that whether these out of this part, whether which part is required, which part is not required, and based on that the cable cost also depend. So we should if we want to optimize the cost of the cable, so we have to optimize the cable construction parts. On that cost depend. So we should aware about each part requirement, and specifications are use of each parts. So we discuss about the conductor or core. Then we discuss about the conductor or core screening, and where this core screening required and where it is not required. So that also we discuss what is the purpose of the screening. And then we discuss third component in cable construction comes is the cable insulations. So we discuss about that whether insulation come and what would be type of the insulations and how this what is the difference. And in that we discuss that mostly we take the PVC and XLPE type insulations. So in that we discuss what is the difference between PVC and XLPE type insulations, right? And, and regarding the conductor or core, we discuss about the materials. We discuss about the shape of the conductors, that where what kind of the materials, what kind of the shape, what kind of the formations of the conductors we take. Then we discuss about the insulation type as well. Then so far part 1 to part 3 we have discussed. This three part study we have discussed. So today we will start the insulation screening part. Is it isn't it any like any query regarding the study class? If anyone have any query, so we are discussing on the cable constructions, and this we are discussing so that we can prepare a technical specifications for the cable, or we can review a cable data sheet, or we can prepare a cable data sheet. For that purpose, we are understanding about the cable construction. So any query regarding the constructions that we discussed yesterday, like first conductor, this we discussed. After the conductor, which part will come? After the conductor in the cable constructions, if it is the high voltage or medium voltage cable, in that case, screening will come. Otherwise, screening will not come. Third part would be the insulations. So far we have discussed about this. So now we are starting the insulation screening. So before coming on the insulation screening, let us see why, let us see again why we are taking this conductor screening. What is the purpose of this conductor screening? Why we are taking this?
To avoid electromagnetic interference.
This is one reason. There are other reasons as well. And it is not the main reason. It is the secondary reason. What is the primary reason?
Uniform potential.
Voltage gradient, yes.
Uniform.
But uniform equipotential.
To avoid skin effect.
No. Is for the skin
Uniform
effect,
voltage gradient.
for the to avoid the skin effect, we are taking stranded conductor. Right? This type of the conductor we are taking to avoid the skin effect. Right?
Reducing electrical stress.
Yeah, electrical stress that we discussed. So here we have seen that screening maintains a uniform voltage gradient or equipotential across the cable length around the cable core or conductors. So here we have discussed reason: uniform voltage gradient, reduce voltage stress on the insulations, right? Insulation, because when we are taking a conductor, when we are taking a conductor, on that conductor we are applying a certain 220 kV 132 kilo voltage. We are applying on this voltage. So this conductor will have the surrounding electromagnetic field. So this electromagnetic field is stress directly coming on the insulation, right? And since one more another point, that this stress is not uniformly divided. Some place stress is higher, some place stress is lower. So what we are doing, that we are putting one another layer around the conductor core. So it serve two purpose. First, it is reducing the electrical stress coming on the insulations. Second, it is providing a uniform equipotential or uniform voltage gradient around the cable core, and it avoids the electrical discharge as well. So that is the reason that we are taking the screening around the conductor. Now let us see about the insulation and why we are taking the insulation screening. Yeah, yesterday we discussed about the insulation voltage grade as well, the earth grade cable and earth grade cable, and where we should go with the earth grade cable and where we should go with the unearthed grade cable. That also we discussed yesterday, right? The earth grade cable and unearthed cable. So today coming to the insulation screening. So the insulation screening placed over the insulation. Now this is screening. So here we are taking the conductor. Over the conductor, we are taking the conductor screening. Over the conductor screening, we are taking the insulation. And over the insulations, we are putting the insulation screening, and the purpose of this screening over the insulation material is the same as the conductor screening. The insulation screen placed over the insulation with the same objective as the conductor screen placed over the conductor means to provide the equipotential surface around the conductor in the whole length of the cable, and to avoid electric field concentration, avoid and provide the outer insulation, a cover a gap-free surface to avoid electrical discharge. The gap-free surface, what I mean that if you see the conductor, this conductor is the surface is not smooth around the total length of the conductor. So this, if I'm putting a cover over here, so it will provide a smooth, gap-free, gap-free to the insulation. So, and provide the outer insulation, say, cover a gap-free surface and avoid electrical discharge. Because if there would be any gap, so electrical discharge would be higher on that gap for high voltage cable and extra high voltage cable. And this screening consists two parts. So it first is non-metallic part. The non-metallic part shall be applied directly over the insulation of each core. If we are taking 3-core cable, so it will applied on each core, the non-metallic part. Then this non-metallic part is a non-magnetic. It is a non-magnetic semiconductor screen shall be placed over the insulation to confine to bind the electrical field inside the cable only. Means if the is on this insulation the electric field stress is coming, so there would be possibility that uh, this stress electric field may go or will have tendency to go outside of the cable as well, or there would be stress outer insulation of the conductor. So it is confining and it is like a second barrier that it is like putting or preventing this electrical uh, field inside the cable only. So it is confining this electrical field. And we take one water soluble tape shall be placed over the non-metallic screen to prevent water from progressing deep into the cable. So for that we are taking this water soluble tape, and a metallic screen shall be provided over the water tape. So we are taking one another component in the cable, that is the metallic screen or metallic sheath. The metal screen can be sheath. It could be welded or extruded wire tapes or a combination based on the technical specifications of the client, whether they require the wire, they require the tapes. Based on that, we can select, or a combination of that. Usually we select copper tape applied over the non-metallic part. So this is our another screening. So if we see again, let us see again the cable, So here I'm just taking the main part of the cable, So here we have the conductor. This black one is the conductor screening, and then this one B is the insulations, and after the B, this one, the black one again, it is again semiconductive part that we are putting here. And here you can see that we are putting one water soluble tape as well. And the next is the C. This C, if you see, this is metal, copper metal. You can see it is just like a copper metal. Copper metal. Here we have the aluminum. So this is our metal screening, our metallic sheath that we are taking inside the cable. Copper wire earth screen. Copper wire. It is copper wire earth, because this screen will connect to the earthing system. Due to this reason, it is written as earth.
Sir, sometimes they are using the cover tape also, no?
Yeah,
Receive.
paper as well. Screen, like paper also, we have some example for the paper as well. Yeah, yeah, sometimes they take paper as well.
So last sheet of the 5 number. There
Yeah.
also.
on all sides of the cable, and then MDPE. MDP means overseas outer insulations, PE, PVC, outer insulation. So now we are discussing about this. So in this cable, the three component is very crucial. Three component is very important component. Obviously, the conductor is very important. Over the conductor, insulation is second important component of the cable, and third very important component of the cable construction is their metallic sheath. This metallic screening, it play a very important role. So in the cable installations, even though we are taking this in the cable constructions, but during the installations we have to deal properly with this cable screening. So we'll come on the installations aspect of this as well. So let us see why we are taking this. Why we are taking this.
Excuse me, sir.
Yeah, yeah.
Is this the armor of the
No,
cable?
no. We discussed yesterday. We discussed yesterday about the armoring. We discussed yesterday about the armoring. This is a kind of
Okay.
the armor. This is a kind of the armor, but it is not the armor. This also serves the purpose of the armor.
Okay.
This also serves the purpose of the armor. So here we have discussed that usually armoring is used for mechanical protections up to 33 kV cable. So up to 33 kV, all LT cable, all HT cable, we take armor. Up to 33 kV, we take armor. Above 33 kV, the metallic sheath also mechanically protects the cable. So armoring from the cable can be deleted or can be avoided. Otherwise, there is few client, like I was working with few utility, like Getco is one utility. They are asking both the metallic screen plus the armoring, both they are asking in their project. So otherwise, when we are taking the metallic screen or sheath above 33 kV cable, then armoring can be avoided. But for LT cables, like we can go with the armoring. Metallic screen or sheath we take only for the medium voltage, high voltage, and extra high voltage cables. And in the high voltage cable, again, it is the choice. Some company, some client take screening, some clients take armoring, some clients take both screening plus armoring. So it vary based on the specifications. I have like open one cable technical specifications. So this is XLPE cable 33 kilovoltage. This is West Bengal State Electricity. This is also utility company. Let us see what they are asking in the cable, what part they are asking. Like, so electrical characteristics of the performance, this cable constructions, that we are discussing. So aluminum conductor screening they are asking. A semiconductor screening, this shall be extruded, this, okay, then fine. Insulation screening, and here it is important. So when we are selecting the cable for any project, this is, I'm discussing a overall part of the cable constructions, but at that moment, because this part directly impacting on the cable cost. So when we work for any project, so we see that what is the client technical specifications, technical requirement, which part they're asking, which part they're not asking, and accordingly we will select the cables. If we have any possibility to avoid any part, we can avoid that. Our like responsibility is to meet the technical requirement. So they're asking insulation screening. So combination of black extruded semiconductor compound, semiconducting and tape as non-metallic part, so that we have discussed non-metallic part, and annealed copper tape lapping as metallic part. Metal screen eliminates tangential stress. See what they are putting here. This metal screen will eliminate the tangential stress of rotating electrostatic field surrounding the conductor and uniform electrical stress in the insulations. Metal copper screens should be able to carry short circuit current of 1 kiloampere for 1 second. This is very less current anyway. So now they're asking both part. Let us see other things. Semiconductor, this cell be extruded over the this for single core aluminum wire armored cell be. Now other part inner sheath armoring. Now they are asking armoring as well. Galvanized round steel wire galvanized form wire for 3 core core cable as per the IS. So single layer of round hard point arm aluminum wire for 1 core cable. This means now they are asking the inner sheath also they are asking, right? So they're asking. So when I will work for this project, I will see the constructions and I will see that they are asking the conductor and they're asking about the aluminum conductor, not the copper one. Aluminum conductor, right? Conductor screening, insulation, XLP, and then insulation screening they are asking. Then they are asking both in the insulation screening, the non-metallic part plus metallic part. The semiconductor screen shall be extruded over the this copper tape shall be wrapped over the semiconductor tape extrusion for 3 core cable. The metal screens so form around the core shall be contact with one another as the cross laid. This for single core cable aluminum wire armory shall constitute the metallic part of insulation screen. Conductor screening, insulation and insulation screening shall be extruded and triple. This is the part of the manufacturing that they are putting, the triple extrusion. This is the manufacturing process of the conductors. The mechanical and chemical property of this material, inner sheath, armoring, outer sheath, and then identification. Means, as I mentioned that, so this is the overall part, but this part, the above cable part may change as per the project requirement, project technical specifications. Am I clear with the part and with the approach? With the approach. Approach is when we are working for utility, go with this. Approach when we don't have any specifications. So I have taken this as a general specification that generally we take this kind of the cable parts. So if we don't have any specification, then we can go with this. Clear? If it is clear, so at least say as. If it is not clear, so at least say no. Do not say
Yes.
material there.
Yes, sir. Clear.
So, what is difference between the outer sheath, that is the armoring with?
I'll come on that. I'll
Yeah,
come.
fine,
I'll
fine,
come.
fine.
Outer sheath is. I'll come on that. Let us go one by one part.
Yeah, yes. Sorry.
Conductor, then screening, then insulation screening. So we are discussing the insulation screening. So what we discuss. So what is the conclusion now? This cable have the two screening. The first screening is this conductor screening. So we can say that we have two screening for the HT cables. I'm talking for the HT, HV, and extra high voltage cables. So we have two screening for the cable, the semiconductive screen and the metallic screen for the power cable. The semiconductive screens is the inner cone. Sometimes we call it the inner core, inner cone, inner conductor screening. Semiconductive inner screen or conductor screen. So this is the, as already we discussed. So one is the screening over the conductor, and the purpose already we have discussed. Again, same thing. It protects the insulation from the partial discharge since the conductor surface is not smooth and includes sharp edge air cavity. This lead to a high electric field stress on these spots, which finally result in partial discharge at this point with heating to the insulations, and subsequently a complete breakdown of the cover may occur. So to avoid this, we are putting a screening over the core or conductor of the cable. So, second screening is the insulation screening, and in that we are taking this metallic screen, or we are taking the metallic sheath. It is the semiconductive screen. It is the metallic screen. So this metallic screen, it is a metallic part, means current could flow through this. It act as a second screening to eliminate the electric field strain outside the insulation, and it is bonded to ground to provide a safe fault current return path, or a safe path for the fault current to flow through the metallic screen. And if this screening is not providing a safe path to flow for the fault current, if it is not used, the fault, when the line to ground fault is happening, or if uh, in that case, if it is not used, the fault current will pass through the surrounding ground level, surrounding ground surface, surrounding metals like pipes, train, rails, any surrounding metal. Through that, this ground line to ground fault will flow. And this will induce a high voltage on these surrounding surfaces, which may danger the humans, animals, or any one which is coming in their effect. So if we are providing this, so we are like protecting. Second, whatever the capacitive charging current in the cable we have, so those capacitive charging current also flow through the metallic screen or metallic sheath of the cables. So I'm just comparing that we have two screening. So what is the purpose of both screening? Now let us see in the detail about the metallic sheath or metallic screen which is applied over the insulations. So now the point is that, so here we have the conductor, on that we are applying the voltage, and current is flowing. Whatever we can say, suppose this is 220 kV voltage applied, and whatever the load current which is flowing through the cable, through the conductor. So what will happen? This will produce the electromagnetic field around the conductor, right? The EMF will generate, electromagnetic field will generate, and this conductor, this applied voltage is sinusoidal voltage. Means a sinusoidal EMF will produce, and which will induce a sinusoidal magnetic field. So if any metallic part coming in the exposure of that sinusoidal magnetic field in that metallic part, the voltage will induce, which is the Faraday law, Faraday induction law, right? The Faraday induction law, what they are telling. Faraday induction law, just you take the example of the transformer as well. The whole transformer working on the Faraday induction law. The whole transformer is working on the induction principle, right? You are applying the volt like power to this primary winding, and here we have the secondary winding. So what is happening? Through the induction only the voltage generating, right? No? Through the inductions, the voltage generating. The same principle applied in the cable as well. Same principle applied in the cable as well. My metallic sheath, in the metallic sheath, the voltage will induce. The voltage will induce. The voltage will induce. This, if when the voltage is inducing on this metallic sheath, and if in case we have done the earthing or grounding of this metallic screen in order to provide a path to flow the fault current. So in that case, in the healthy phase, in the healthy conditions as well, in the normal healthy conditions as well, what will happen? This both end grounded. So ground, it will, there would be a closed path created, a closed path will form. So what will happen? Through the metallic sheath, the circulating current will flow. Through the metallic sheath, the circulating current will flow. Right?
Yes, sir.
the circuiting current will flow. So if in case you are not bonding, if in case you are not doing earthing or grounding of the screen, then voltage inducing. When you are grounding, then current flowing. Means we have to manage both between voltage and current, right? We have managed between both and current. And what will happen if in case some transient or voltage applied, and in that, if in case there is any short circuit happen and higher current flowing through the conductor, so this will induce a higher electromagnetic field, and this will induce a very high induced voltage, and this will induce a higher circulating current through the cable metallic sheath. So this kind of the current which is flowing through the cable, we referred, and this is not, this current we are not utilizing for any power transmissions. So whatever the losses which is coming from this induced voltage and circulating current, this kind of the losses we refer as the sheath losses. So in the cable, there is two kind of the losses. One losses which is occurring through the cable, conductor, core, and another is the sheath losses, right?
Sheath losses.
So let us see this. Let us see this. And I hope this point is clear. I hope this point is clear. It is. It is clear. Please let me know, because I am now going in the direction of the sheath voltage limiter, link box, bonding. In that direction, I am entering. So this is the basic point. Is that basic is clear?
Raghav sir,
Yeah.
hello. Sir, in between the conductor and this sheath, there is insulator, is there? Yes. So how it will be?
In the conduct, but the field will come over the insulations field. This electric field will come, and there would be capacitance also formed between that. Induction law will work in that case. So now, like you refer the capacitance. What is the capacitance? There is two electrode, right?
Yes.
Siju?
Yes.
So
Yes.
when you
Yes.
are applying the like charge here, here is the insulating medium. This is your which is your insulation in case of cable, you assume, right?
Yes.
But again, here the charge is inducing, right? Which is
Yes.
the
Yes.
capacitance.
Yes. Yes.
That what? So it is also capacitance. There is two metallic part between there. You have the insulation, right?
Yes. 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 It's clear, sir. It's clear.
Yeah, same in your transformer take. Now, what is there is no electrical connections induced.
Yes. 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 It's clear. It's clear.
Okay, let us see again this point. So as we know that about the screening, so we discussed that there is two screening. Now we are taking the insertion screening. So as we know, the conductor with sinusoidal AC current will develop a sinusoidal electromagnetic field around the conductor. This is statement number one. Statement number two, if a metallic sheath is exposed to an electromagnetic field, this metallic, the voltage will induce by Faraday induction law on the metallic sheath, and the circulating current in the screen will start flowing if the sheath is connected to ground or to earth, and a closed circuit is formed through the earth connections. Then circulating current flowing. The induced voltage is directly proportional to the current passing through the cable core or conductor. In case there is transient over voltage conditions, a high transient current pass through the cable core. Also, if in case, second case, a short circuit condition somewhere occurred, so high short circuit current passing through the cable core, a high current flow through the cable core, and then a high voltage will induce on the metallic sheath. So when the sheath are ungrounded during the short circuit conditions or during the transient condition, a when the sheath are ungrounded during the short circuit conditions, in that conditions this high voltage will induce. I'm grounded, if I have done grounding, then what will happen? Voltage will induce, but current will also flow, and that current will enter into the ground. Then, if current is entering into the ground, I have provided a grounded point. In that case, the voltage will be 0. Means, please try to connect with me. So this graph is like that. If earlier, initially, when there is no any, when I have done the solid grounding, here I have done the grounding, and I'm taking the voltage over the sheath. So at the grounding point, the voltage induced on the sheath is 0. And when I'm moving away from the grounded point of the sheath through the length of the cable, then the induced voltage on the cable sheath keep linearly proportionally increasing, right? So if I have done grounding, so what will happen? If I have done grounding, so what will happen? Then this graph would be like this. Here 0, I'm in when I'm going away, voltage inducing, but at the end again I have done bounding here. So what will then? My induced voltage is 0 here, but what is the disadvantage? Grounded here. This grounded, even though this ground is away, 10, 50, 20 kilometer away, but this Mother Earth will provide a common path, returning path, common path. Then circulating current will start flowing. Circulating current start flowing. So we have to deal with the two parameters at the same time, voltage and current. Means when you are suppressing one, other is increasing. So in case of
Sir, in ungrounded state, charging current.
The induced voltage is directly proportional to the current passing through the cable or conductor. In case of transient over voltage, high transient current pass through the cable core, and also during a short circuit, a high current flow through the cable core, and then a high voltage will be induced on the metallic sheath. When the sheath are ungrounded, then a high voltage inducing. Ungrounded during the short circuit conditions and during the normal conditions as well. But during the short circuit conditions, this induced voltage would be very much higher. Therefore, bonding of the sheath and grounding or earthing of the sheath in the cable, earthing of the cable sheath is usually considered as a good practice for the high voltage and extra high voltage cables. So from here to here, am I clear? From here to here. Do not go with the SVL. This is second statement, but my first statement is clear.
Yes, sir.
Sir, in case of ungrounded, so circulating current is not produced in that condition.
Yeah, yes, it will not flow circulating current. Yes. But current not flowing, but what happening? Your voltage is floating voltage. Your voltage is higher. Voltage inducing, they are not getting any path, but voltage inducing. And suppose this current get any transient over voltage, transient or short circuit current flowing, then this induced voltage would be very much higher, at very much higher. And this, if this is coming this higher voltage will be surrounding to the ground, and any metallic, any pipeline, any railway line, if it is exposed by the chance, at that moment, a in the surrounding high current start flowing. Yeah, if not ungrounded, then voltage will be there, current will be zero. Okay, Visa?
Okay, okay. And insulation requirement will also be increased if
Yeah,
voltage is
yes. So in both we have to deal. So now my statement number 3, statement 1 is the electromagnetic field. Statement number 2 is the circulating current and the induced voltage. Statement number 3 is the Sheath voltage limiter, this divide, this SVL. This is very popular terms in the cable engineering, the Sheath voltage limiter. This is basically a surge arrestor, but I'm using in for the cable. So for the cable, the surge arrestor rename as a Sheath voltage limiter. A type of the surge arrestor device is also connected between the metallic sheath and ground to protect the sheath insulation against the induced over voltage. Taking the same example. So now suppose one side I have done the grounding. Here circulating current will be there, but they're not getting any path. Uh, but here the voltage would be zero, and when I'm going away from the source, then on the other end of the cable sheath, voltage is inducing. So if in case I will do direct grounding of the second part of the metal sheath, so it will start circulating current. So what I am doing, I'm not direct grounding here. I'm putting a, I'm putting a, I'm putting a SVL. So what they are doing, if the voltage, if the voltage coming based on the rated or required voltage, if the voltage inducing under the prescribed limit, then this SVL will provide this is a non-linear resistance. If voltage is rated voltage, then resistance would be too much high. And if the voltage is above the rated voltage, then resistance would be too much less. So it means if the rated voltage coming at the desired voltage coming off the sheath over here, then SVL provide a open path. And this terminal would be treated as an open terminal, floating terminal. But when the voltage on the sheath is inducing very much high, and why that voltage will induce due to the transient and due to the short circuit current flowing the conductor, due to that reason, the voltage may induce very much higher. So at that portion, in order to protect this sheath and the insulation as well of the cable, this SVL coming, and when the voltage inducing higher, it will provide a low resistance path, and this part would be grounded. So temporary circulating current start flowing, but it is circulating current start flowing, but it is protecting the cable insulation against the damage. Am I clear that why we need to take the Sheath voltage limiter?
Yes, sir.
Why we take Sheath voltage limiter? I will come on the side photo, but before uh, coming to the side photo, we are discussing the basic concept. So is also connected between the metallic sheath and ground to protect the sheath insulations against induced over voltage, right? But once the cable is bonded and earth The circulating current in the screen also develop, and it derates this circulating current derate. I'll come on that, Joseph. Hold on. Once the cable is bonded and earth, the circulating current in the screen also develop, and this circulating current derate the cable current carrying capacity due to the extra heat, due to the extra current which is flowing through the circulating current. So this current will also produce the heat due to the Joule law, I square into RT. So this extra heat in producing in the cable, so circulating current in the screen will also develop, and it derates the cable overall current carrying capacity due to the extra heat, circulating current heat due to the Joule effect within the cable. So suppress one, when we suppress one, when we suppress the current voltage increasing, when we suppress the voltage and we are doing the grounding, the circulating current start increasing. So once we suppress one, other start increasing. When we suppress other, another will start increasing. So we need to balance between the induced voltage and the current. So in order to make the balance between the induced voltage and current, there is different cable sheath bonding and earthing method has been developed. And this bonding and earthing and sheath voltage limiter, this device, we place in a separate enclosure. This enclosure we called as a link box. So a link box is used with the high voltage cables to create the sheath bonding, sheath earthing, and to place this SVL equipment, because this is the equipment that we have to place somewhere. So we are placing in the link box. So this is the concept. Let us see this concept how implemented at the site. So now you can see cable, underground cable coming, as already we have discussed. Underground cable coming, underground cable coming, and now this underground cable is terminating at the substations at one end. So when this is terminating, so what equipment have been used? This is our support structure in order to support the cable, right? This could be a type of the post insulator. This could be. So here we have the cable, and here we have the cable sealing end. Our important consideration, our the whole discussion is around the. Could you see this cable now? The yellow marked cable. The yellow marked cable.
Yes.
Let me take the snapshot. Yeah. So now here cable is terminating. Is that cable sealing it? This is the sealing in SE. Sometimes we write as a SE, sometimes we write as a CSE. Both have the same meaning. Cable sealing int. Support structure. HT cable. This is my HT cable. This is our clamps to support to fix the cable. This small portion is your is your is your metallic sheath or metallic screening, right?
Yes.
And this screening going into the box. This box I have done a lot of marking here. So see here. See here. Metallic. This is our
S
cable,
SVL box.
cable link box. Link box. In the link box we do the earthing, and in that box we place the SVL. So cable metallic sheath. So here metallic sheath entering into the link box, and through the link box we are doing the grounding. Let us see. Let us see some internal view of the link box. So now here I have taken the sheath, and this sheath is entering into the link box. This is just a link box. You can see here 500 by 500 mm that kind of the IP65 link box. And this is our link. This is a removable link. This link we can remove. And this is the example of the solid earthing, because this cable is screening coming and directly connected to the ground. So this is the solid earthing. So as we discuss, what we discuss at one side, what we are doing, the solid grounding, right?
Yes.
This is here, one side. Another side, what will happen?
SVL.
Another side, what will happen? Cable, sheath box going to SVL, and going to link box. In the link box, we have the SVL, and through the SVL, we are doing the grounding. Right?
Yes.
Why we are
Yes,
using
sir.
SVL? Why we are using SVL? Let us see one more example. Could you see this example now?
Yes.
I don't think it is too much clear, but I think it is like are serving our purpose. So now here what we are taking, what is this? What is this cone? What is this cone? What is this cone? This is our
AC, cable
SC.
cylinder.
This is our SC. SC. The red one is what? The red one?
Cable.
HT. I will come about the ECC later on, so you don't focus ECC now. This is 500 kV underground cable. This one. I'll come ECC later on. But before the ECC, what then? Taking one conductor, which is coming into the
Link box.
link
Link
box
box.
with
SVL.
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 Link box without
Out SVL. Direct
SVL.
solid earth.
SVL. So means it is in the drawing we indicate like that. This taking all the metallic sheath,
Enclosed.
inserting into the link box where we have removable link. This is how we represent into the drawing. This is how we like, where is the link box? This is how we install at the site. Right, and link box without SVL. It is grounded, solidly grounded. Right. So either now you see what they have done, how they are doing this. They're taking 1, 2, 3, making one common, and then it is grounding, right? Then it is grounding. What is the meaning of this?
Solid earth.
No, it is
Or equipotential, sir.
it is solidly here. That's correct. But what is another meaning of this representation? Are you feeling like that this is R phase, Y phase, B phase, because there is 3 conductors, right? So R phase, Y phase, B phase. So R, Y, B all coming
Star connected.
Star
Star connect. Star points.
star neutral third point.
due to this reason I took this point. It is a kind of the presentation, but it is not a star. It is not a star. It is not a star. Due to this reason, I highlighted this point. No star making. Take the screening, put in the link box, do the grounding. Take screening, put in the links box, separate grounding. Take screening, put in the link box, separate grounding. Now what we see, this ground is common, right?
Yes.
So either I can represent like this, or since this is the mother earth that is common. So instead of representing 3 individual grounding, we can do like that as well.
Okay, sir.
Both have the similar meaning. But we need to know one another topic, that whether this is a 3 numbers single phase link. single phase link, right? So whether I'm using the 3-number single phase link or I'm using a common link, this we should also aware. This should we also know. Because in case of the extra high voltage system, most of the time cable we are using single core cable. So due to this reason, 3 single phase are 1 3 phase we will take. But anyway, before coming, am I clear? So I'm discussing about the screening in insulation screening. In that, I'm discussing about the metal sheath. So am I clear about the why we take the metal sheath? Like then we discuss about the induced voltage on the metal sheath, circulating current on the metal sheath. Then we discuss why we have to take the SVL, and we discuss this both SVL and grounding is performed in a separate box. That box called as a link box. So this link box have a link, this kind of the link they have. And this link box, how looks like at the side, outer and inner, this in link box. Now, let us see about the link box selections. So link box is a kind of the box in which the bonding and earthing connections are made through the removable links. This one link that I'm telling. The box also has a sheath voltage limiter. In this box, it is not available because we use two kind of the link box. One with SPL and another without SPL. So this example side photo is the without SPL. Without SPL. And this we indicate into the drawing like this. Like just to, if you see here, this cable we have taken and then here we have indicated one jet. This kind of the symbol we make to indicate the SPL in the drawing. This kind of jet, and then it is going to the grounding. So the box also has a sheath voltage SPL device to protect the sheath insulation against induced over voltage. Voltage will be there, but if voltage coming above the limit, then those voltage we are telling as over voltage and is connected between the metallic sheath and ground. That we have seen one example of the cable grounding system. This is how we prepare the drawing for the cable grounding systems. The link box can be 3-phase type or 3 into single phase type. When we have a single core cable with an individual termination support structure, we use a 3 into single phase type link. So this is a 3 into single phase type link, right? One here,
Yes,
one
sir.
here, one here,
Yeah.
3 individual support structures. So this is a 3 into single phase type link. And all 3 cables sheath are individually connected to the ground. When we have a common support structure, in that case, a 3-phase link box also can be utilized just to save the cost. Cost saving. I don't think I have the photo. If I have photo, I will show you. Could you see here? This is another side photo in that there is a common support structure for all the 3 core cable. So if you see here, I'm taking this cable, I'm taking this cable, I'm taking this cable. It is coming in a common link box
Yes, sir.
and then grounding. So this is a 3-phase type link box. So means it is not very important. We can go with the 3-phase type, or we can go with the single phase type link box. And generally, if we have single core cable, usually we go with the single phase link box. So let us understand now. Let us stop here and let us understand now. So in the overall electrical system, there is 2 pieces of equipment we are using in order to protect against the over voltage. One is the
Surge.
conventional
Surge
surge
arrestor.
and another is the
SVL.
SVL. So we have 2 type of the devices to protect against transient over voltage, surge arrestor and sheath voltage limiter. So surge arrestor protects the transmission lines when it is connected in the line at that moment, and it protect protect the transmission line, and protect the connected equipment against lightning and switching over voltage. Whereas the SVL is used to describe a surge arrestor that protect any part of cable sheath insulation against transient over voltage. And this SVL connected between the sheath and the
Earth.
ground earth. Am I clear?
Yes, sir.
So we are doing a bit comparison between the cable over voltage protections and the electrical equipment over voltage protections. So we are using the SVL. SVL is the same as the rest of it, non-linear uh, device which provide the low impedance when over voltage coming. So now, as we discussed that we need to balance between the voltage and current. So in order to that, here may be armored. I'll come on the armored bit.
So do you have a side picture of SVL also?
Actually, I asked some of my site engineer if they have, but unfortunately I could not get. Otherwise, definitely I have used in my presentation. I was I was trying to arrange, but I could not arrange so far. But even though I have communicated with few site engineers, if they have any link box with SCL, they share with me so that I can share with all of you. Anyone who work in the cable installations, erections of high voltage cable in the class, if anyone have site photo, if they can share. Is it anyone in the class? How it looks like internally, this just we wanted to see.
Sir, in Google availability.
Yeah, Ravinder?
In Google, say the voltage limiter photo available.
Okay,
In Google.
if it is fine, you share with me. I can open here now. Yeah, you do this search for me and share with me. Okay, now let us discuss about the cable bonding and grounding system, earthing system. So different. So now coming to the different sheath bonding and the sheath earthing system. Now we are discussing this sheath bonding and sheath earthing that we have indicated sheath earthing. So what is the total different way of sheath earthing? So sheath bonding and earthing system, different sheath bonding and earthing system are used. Different type of the sheath bonding and earthing system are used depending on the voltage, depending on the cable length, cable length, cable length, cable length, cable length, and the cable application. Below are a few popular or most used cable sheath bonding system. So first is solidly bonded system. So far we discussed about the solidly bonding system. Second is the single point bonded system. Solidly bonded system also called as also called as both end bonding. Both end bonding. It is solidly bonding system. Second is the single point bonded system. Means in a length of the cable, at only one point we will do the bonding and earthing. Another point would be open terminal. Third is the cross bonding systems. So solid, single, and cross bonding system. These are the few popular cable bonding and earthing systems. Let us see one by one and which kind of the bonding and earthing system we should apply. Let us see that as well. So let us start with the first one, the solidly bonded system. So here it is an example of the solidly bonded system. So now if you see in this picture what is happening, we have the cable. This arrow is indicating the cable sealing end. This black is indicating the cable core, and the green one is indicating as the metallic sheath. So what we are doing, this three, all the metallic sheath we are taking, all the metallic sheath we are taking. Now, do not confuse that all metallic sheath I'm taking and then coming, doing a star or common point and then grounding. Right now, because we discussed now here this point, right?
Yes. Yes, sir.
Okay. So now taking all the individual metallic sheath and then directly grounded, which is called solidly grounded. Here, this is my sending end, this is my receiving end, this is one end, this is another end, and the another end again I am doing and then grounding. So it means it is very simple, both end grounded. Solid grounded system is typically used on medium voltage up 3.3 kilovoltage, 6.6 kilovoltage, and could be used up to 66 kilovoltage. Till that it could be used. Solid bonding is not commonly used on extra high voltage cable. This method is not used in EHV cables. This method used in medium voltage and high voltage cable till 66 kilovoltage. Above 66 kilovoltage, it is not used. And sometimes it is used in submarine cables, except on the submarine cables. It's not opening. Yeah. So it is not even the EHV cables. So in this system, cable sheath are solidly bonded at both end of the cable line. It is simple, low cost, as we eliminated low cost options with minimum maintenance requirement, but it has its own disadvantage. In this type of the connection, what is the main disadvantage? Both
High
side,
circulation.
both side earth. So what is
High
happening?
circulating current. High circulating current flow, sir.
This
Yeah.
current,
So temperature increase.
this here current getting a common mother earth closed path form. Circulating current start flowing. So in this type of the connection, high circulating current in this screen start flowing. When current flowing, current producing the heat current producing the losses, which is called as the sheath losses. Uh, Heat produce the losses because of the Joule effect. Which so when this losses coming, it will increase the cable's rated current carrying capacity. This is a major disadvantage of this kind of the both side
Bonding.
earthing, both side bonding, solid bonding system. It is used for small connections. Small connections, any 100, 200 meter connections for medium voltage and high voltage cables. Small connections, in that case, it could be this kind of the system could be used, right?
Yes,
Let us
sir.
let us see the next type of the connection, which is single point bonded system, which is mostly used in the substations. I hope that you have heard that in the substations we do a single point earthing of the armoring, right?
Yes.
Armoring earth at the switchboard end. This kind of the common engineering practices we have here.
Yes, yes.
Armoring earth at switchboard at one terminus. Why? To avoid the circulating current. Single point bonded system. Cable sheath shall be bonded and at only one point. So when I'm doing this, so there is an open system at another end, open system. So when other end is open, then there is no any closed path and then no any circulating current. The current does not circulate. within the screen. So there are no losses because of the Joule effect, because of the circulating current in the cable now. Single point bonded improves the cable current carrying capacity by eliminating the power losses in the cable sheath. Eliminating the power losses in the cable sheath, and it is not improving, but it is not decreasing at the same time. This we can say. Single point bonded system not decreasing the cable current carrying capacity by eliminating the power loss in the cable sheath. This method is used within the same substations and can be used for cable length up to 2 kilometers. Sometimes I have seen for 3 kilometers as well, but generally it is limited up to 2 kilometers. So if we have substations, in that case we have the same equipment placed in this below this length. So and those kind of the situations we take single point bonded system of the cables. So this method is generally used when connecting the power transformer to 33 kilovoltage HT panels and sheath is earth only at the switchgear end. Suppose you have the armor, so same concept apply for your armor as well, right? Single point bonded earthing system of the cable armoring, and that would be at the switchgear board, HT board. It is also used when we have a earthing transformer. Sometimes when we have delta configurations, power transformer. So in order to create a imaginary grounding, we use a earthing transformer. This we will study in the earthing module about the earthing transformer. But if we are using a earthing transformer, in that case, 33 kilovolt sheath is only at the earthing transformer end, not the power transformer end. This is statement number like 1 is this, second is this. Now third statement. Since if you see in this method, so how this is the example of the double bonded system, solidly bonded system or single point bonded system. This one. This is example of the
Single point, sir.
are solid bonded.
Solid.
Solid bonded, right?
Yes.
How solid bonded? Yeah, where I have done solid bonded.
Single point, because there's a single point, sir. One side is the directly earth, and another side use SUL.
See,
So, sir,
here you are using the SVL. SVL means what?
yes, sir.
SVL means what?
Yeah.
Surge
One
arrestor.
type of the yes, sir, the arrestor,
Surge
sir.
arrestor means high impedance.
Yes,
It means open circuit. This will
open circuit.
provide the open circuit.
Yeah, so single bond is
because it is providing a very high impedance. So in the open circuit again get high impedance. So this point is open. This point is solidly earth. So it is an example of a single point bonding. Am I clear? Why not? It is
clear, sir.
example of, if it is example of single solid bonding, in that case SVL delete. Right? Am I right or not right?
Yes.
Right, sir.
Yes.
Delete the SVL, delete the SVL, do the direct grounding, do the direct grounding, SVL delete, then both end earth. So now, since you are not using the both side grounding, you are using this kind of the sheath voltage graph here, grounded. So 0 voltage, sheath voltage 0. And at the same time, this second terminal is not connected to the ground. It is open. It is open. So when any fault happening, there was a very advantage of the solid bonded system. That solid bonded system is also providing path, a path for the fault current, right?
Yes.
For path current. Means suppose fault happening here. So few portion of the fault is splitting and it is going back towards the source, right? Or towards the another end, towards the another remote earth it is going, right? Remote earth it is going.
Yes.
So ultimately we are able to reduce the ground potential or earth potential rise of this substation, this plant. This is we are getting through the solid bonding, right? This point keep in the mind when we will come into the earthing. We will discuss about, we will calculate the ground current. In the ground current, we take the like full fault current, then we take the IF, then we take the SF split factor, and then we take the derating factors. So by multiplying these factors, we calculate the ground current. So this split factor SF is that is this is my that how much if the fault happening, so how much current is splitting between the local and remote earth. So this solid bonding providing the current splitting. But if I'm not doing a solid bonded uh, solid grounding of the sheath, then open terminal we have. In that case, what we do, we use another cable. This cable is called as the earth continuity cable. So if you see here, one grounding here, right? Between this grounding, so this ECC cable parallel, running parallel to the, running parallel to the, running parallel to the power cables.
Yes, sir.
Means you are putting a three core cable, three cable you are putting, but you will see that at the side four cable has been used. So the fourth one is your ECC cable. So this ECC cable, now this ECC cable is connecting this point and this point, and they are providing a safe path for the fault current, a low impedance path for the fault current. And at the middle of the total length, suppose this cable length overall is 100 kilometer. So at the middle, at 50 kilometer, we do the transposing. We do the transposing so that the vector sum of the induced voltage and induced current on the ECC cable would be 0. So due to that reason, we do the transposing at the middle point of the ECC cable. So am I clear? The like why the ECC cable? So this why the ECC cable? Single point bonded system. For single point bonded system, an ECC cable is installed in parallel with the power cable when the cable length is longer. ECC is a conductor that joins two separate points on a cable sheath to reduce the fault path impedance between them and provide a safe path for fault current. I'm discussing too many concepts one by one, so like
Sir, ECC providing the 66 kV also, sir? Means 33, 66 kV? Because I'm generally sure not using 66 kV, sir.
for the
ECC cable, sir.
because uh, it is used for the longer length, not for the shorter length. If we have the longer length,
But,
it's used.
sir, I am
For,
showing the minimum 10 kilometers length, sir. So I'm asking.
yeah, no,
Yeah,
yeah.
more than, yeah.
Actually, for the EHV, we use this for the extra high voltage. For the 132 kV, 220 kV, for those we use this.
Okay. And, sir, length means, minimum length means 1 kilometer, 10 kilometer, which is your minimum length for ECC cables?
Up to 2 kilometer, we are using this single point bonding. This ECC
Yes.
cable, this ECC cable is coming if your cable length is in the range of 40-50 kilometer. Means for a higher cable length, it is
That means the transmission line purpose.
yeah, for the power transmission purpose.
Okay, sir.
Yeah. So
Hello, sir.
yeah, let me finish. Let me finish.
Okay.
So so here it is one another example. Here it is one another example. So this is a single point bonded. So ECC cable, now cable, ceiling int, then cable. Now the ECC cables. This is my solidly bonded, and this is my bonded through the SVL, sheath voltage limiter. So only in single point bonding system, only one end of the metal sheath is directly grounded in the earth link for single point bonding. The other end of the metal sheath is open and connected to the earth with an SVL, with a SVL. The SVL is to protect the cable outer insulation or sheath insulation at the open end from electromagnetic transient or lightning and switching over voltage transient. This is the use of the SPL. So in the open end system, which is your single point bonding system, it is open end system. High induced voltage levels are produced. This high voltage level will produce at the open end, right now, at the open end means at the open end. So if I'm taking the voltage across the length, so this is my open end. Here I have done the solid grounding. So here my voltage would be 0, but this is my open end. So here a high voltage will induce. So what I'm doing, that I'm putting a sheath voltage, SVL I'm putting. This is how we indicate the SVL. And then through the SVL we are doing the grounding. SVL we are putting here. So at the open end, high induced voltage levels are, and here high induced voltage producing. SVL is installed between the sheath and earth to ensure the allowed induced voltage value in the sheath not exceed in case of a fault, in case of a lightning, in case of a switching over voltage coming and then inducing over voltage on the sheath. So the voltage on the sheath should not be exceed above the allowed limit. Let us see what is allowed limit, how much voltage generally we allow. So I have taken a technical specifications screenshot for the sheath voltage. So here I am taking the cable length and distance, and here induced sheath voltage. So this is a graph between voltage and length, which we are drawing since beginning. So now if you see here, we have, this is my voltage. So now at the starting point where we have done the solid earthing, voltage is 0. When the cable distance is increasing, the sheath voltage linearly increasing. So the specification is telling that the sheath voltage should not go beyond 65 voltage unless otherwise agreed with the engineer. Sheath bonding and earthing arrangement shall be such that standing sheath voltage at maximum declare full load current, because my voltage inducing on based on the current. So at full load current shall at no point exceed the following historically accepted values. 65 voltage is screened to earth for system voltage up to and including 132 kV, and 150 voltage is screened to earth, this voltage for system voltage between 275 kV and 400 kV. So left side is an extract from project technical specification for maximum sheath voltage. So whenever the sheath voltage increase above the desired our maximum limit, which is 65 mm 50 limit, we have to break the metallic sheath.
sheath.
We have to break the metallic sheath. And because if I'm not breaking the metallic sheath, when the cable distance is increasing, the voltage keep increasing. So we have to break the metallic sheath. And SVL needs to be connected between the sheath and ground. So in long length cable, we go with cross bonding method, which is to be done at regular interval in the cable installations. Let us see the cross bonding. Let us see the cross bonding. And before that cross bonding, here, if you see this kind of the cable installation photo, if you have seen. So what is this? What is the small one? What is doing here? What is doing here?
Cable jointing.
And
Cable jointing.
and your
And the screener. Cross bonding.
Screening, cross bond.
Screening.
Screening connect to the another cable, sir.
yeah. And here you are breaking the sheath as well.
Yes.
Breaking the sheath as well. Why breaking? Because so we measure the sheath voltage, and if like what we are doing, that when we have suppose a 10 kilometer, suppose in case we are taking a 10 kilometer cable for an example, right? So here, like let us take any long length 100 kilometer. Suppose I'm taking cable. So here what I'm doing, that suppose this is my distance of the cables. So 1, 2, 3, 4, 5, 6, like 10. Like similarly, let us go up to 100 kilometer. Here we have the voltage, and here we have this induced voltage. Here we have the 0. So now at this point, when the 65 voltage coming after the measurement, so what we have to do, we have to now break the sheath. So after the breaking the sheath, what we will do again, and here we will connect the SVL.
0.
Again, as we not the 0, breaking, not grounding, just breaking and putting the SVL. Okay.
Okay.
And then taking the
Okay,
another section. In that case, it is called as the sections, minor sections, major sections now coming. So whole length of the cable divided into multiple minor and major sections. So now taking the another sections. In that sections again, we are taking the cables. So here again, we are getting the similar kind of the voltage, and then again we are going. So again going, again like we are checking the voltage, 65 voltage coming, break the cables. Then again taking the another portion of the sheath. Then keep continue. And when the last coming, in the last coming, at that moment, what we can do? We can do a solid grounding. Solid grounding.
both hands are solid. Both hands are solid
Yeah,
grounding, you sir.
but it is not linearly, it is not going. Means, so either you do the solid grounding, or if we are able to maintain the 65 voltage, the maximum limit voltage, then instead of doing the solid grounding, we can go with the, like, sometimes it vary. Sometimes few company ask to provide the link box without SPL. Some company ask that keep it floating, provide the SPL, and then connect to the ground. So it keep change or keep vary as per the specifications or as per the client requirement. So here I have taken one
Okay, sir.
example of the cross bonding. So now 0, length increasing, 65 voltage, breaking, and then again nearly constant at 2L length, breaking here, like sheath, cross bonding here, breaking the sheath, not the continuous length of the sheath. And then again going, and here again it is 0. 0 means at this point means they have done solid grounding. Solid grounding they have done here in this case now. So if you see here, this grounded, and between that there are multiple grounding with help of the SVL, right? Solid grounding, multiple minor sections, and that all connected with the ground.
So
But
cross
this,
bonding
but
is
this, but
interchanging of sheath.
no, there would be no recirculating current because you are not providing a whole continuous path. You are not providing whole continuous path. That is like you have done you have interrupted the sheath. Sheath is not continuous. Sheath is interrupted. So in case of long length cable, the cross bonding method is used. The sheath is interrupted. Interrupted. Okay, Joseph, sheath is interrupted. Sheath is interrupted at different point for cross bonding. For cross bonding joint. For cross bonding joint. Connection between the sheath so that each sheath circuit connects the three-phase conductor successively. Okay. In this way, induced voltage in the screen circuit are reduced or limited. When the cable length increase, the sheath voltage increase. So we can see linearly increased line. Like here I'm explaining this graph. This is already I have explained. So in the cable, so cable sheath voltage, so we can see a linearly increased graph. At the starting point 0, where the solid sheath earthing done, at this point voltage is 0. And once the length increases going till L, sheath voltage keep increasing. So the sheath is interrupted, and connected to SVL, SVL, and SVL. At that point, voltage is limited. At the second end, at the last end, second end point of the cable, again solid earthing done. Then voltage again 0, right? Am I clear about the cross bonding?
Yes, sir.
So we discuss a lot of things. This is this kind of the site photo we see at the during the cable extra high voltage cable installations. Minor sections, major sections, interruption sheath we do. Let us see few other things. This is a cable ceiling int. Now, one point I would like to highlight here. If you see this supporting plate is not directly connected to the structure. If you see this one as well, not how much it is. So could you see this? Could you see the small insulator here? Could you see arrow where I have highlighted the arrow? This is what? This is link box. Cable ceiling. Cable is coming. Here we have the overhead conductor. Right? This is base insulator. So where cable ceiling int, when we are installing the cable ceiling int, the base plate is connected, where the cable ceiling int base plate is connected to the metallic screen of the cable. It should be isolated from the supporting steel structure, which is connected directly to the grounding system with an adequate insulators. So every ceiling int must be supported on the insulator. Okay. So this I think this already we have discussed. Am I clear? Am I clear on this? So here we have the next cable part, which is the armoring of the cable armoring, this part. You again revise, then let me know, Joseph. I'm telling that this part, the metallic screen is connected to this base plate. Due to this reason, base plate should be isolated from the grounded metallic structures. This is what I'm telling. Yeah, base insulator is correct. Yeah.
Raghava sir, one thing actually.
Yeah.
In cross bonding, that SVL to another end, it is not connected all from the local end to remote end. All will not be connected. The bonding cable.
Come again. Come again.
No, in the cross bonding scheme actually, it will be connected all actually from the station A to station B, or it will be interrupted actually through SVL. Yeah, in this image, sir. The first SVL is there, no? First part actually.
Yes, yes.
The second portion cable, yeah, the second portion bonding cable, it will be connected or it will not be connected.
This one?
Yeah. This are both to be connected or it will not be connected actually. It will break.
See here. See here. Could you see this part coming from here to here, and then it is connected here. There is a cross.
That means it is phase is changing actually from R to B.
Yeah, phase is changing, and also in order to change the phase, you have to interrupt this.
Okay. That is a cross body, right, sir?
Yeah.
Phase is changing. Okay.
Yeah, phase is changing so that your vector sum would be 0.
Okay, fine. Okay.
Yeah, 120-degree apart. So back to the cable part. Where we started. So insertion screening we discussed, and for the EHV cable we discussed about the metallic sheath, and we discussed about the metallic sheath erection or installation at the site. The concept about that sheath installations at the site. Next is the fillers. Fillers means if there is any gap in the cable. So for that we are using the filler. Inner sheath, sometimes we use the inner sheath when we have 3-core cable to combine all 3 core in single cable. Sometimes we take the inner sheath. Right? Then over the inner sheath, for the low voltage, power, medium voltage, and high voltage, we can take the armor. So this armoring, or the use of the armoring or type of the armoring is similar to the metallic screen or seating. It is like providing the mechanical protections as well. So here I have taken one cable example. So in this is a LT cable. So here we have the aluminum core, then we have insulations, then over the insulations we have taken one tape, one cover to bound all 4, and so this you can see as a inner sheath. This you can treat as an inner sheath. In this cable, the metal sheath not used, and just after we have the aluminum wire armored, and over the armoring we have the outer PVC insulations. So this armoring is recommended for protection against mechanical damage. If any mechanical, because this cable is exposed in the environment, so there is a possibility to damage the mechanically to this cable. So in order to protect This mechanically damage the armoring used in the cables, protections against rodent, rat, mouse attacks. This armoring also helpful in that. Armoring material could be galvanized round steel wires or galvanized flat steel strip for multi-core cable. Round wire up to cable diameter of 13 millimeter generally means if this from here to here my internal diameter is coming 13 millimeter. In that cable we will go with the galvanized steel wire, round wire, and above, if this diameter is increasing above 13 millimeter, in that case generally we go with the galvanized flat steel strips to make the armoring. Aluminum material used for single core power cables. We'll go with the aluminum material. And armoring code is designated as below. If I'm taking the galvanized single steel wire, then generally we use W. In the cable code designations, I will come on the cable code designation separately, but here I'm telling us what the word we use. If I'm using the galvanized steel flat strip, then FAW when we have hard drawn single aluminum wire, and if we have hard drawn single aluminum strip, then AS generally we take. But before this coding, this is the selection of the armoring materials generally. Otherwise, if we are working for any project, so we have to see what is the project specifications, and accordingly we have to select the cable armoring. Like here you can see there this client armoring requirement. This is the general practice for the armoring selections. Let us see, I have taken few snapshots from the different publications, journal publications. So armoring selection, it is written in the IETP. This is one manufacturer associations, single core cable, and then aluminum versus steel armor in single core cable. In the case of three core cable, under normal operating conditions, the vector sum of IR, IB and IB, the R phase, Y phase and B phase current, it is 120 degree apart. So the vector sum of the current would be 0 in case of three core cable. Hence, the net flux coming out of the cable is 0. In this case, steel armor can be used. In the case of single core cable, the net flux coming, flux, electromagnetic field that we discussed, the flux coming out is proportional to current in conductor, and it is not 0. Hence, only non-magnetic metal like aluminum is used as a metallic shield or metallic armor in single core cable. Am I clear about the armoring, where we go with the steel and where we go with the aluminum? Aluminum for single core cable, right? Steel for the three core cable. Steel could be wire and could be flat strip, steel strip. Wire till 13 millimeter, above flat strips. Now next part of the cable, which is inner sheath and outer sheath. Sorry, outer sheath. Inner sheath is the before the armoring. So outer sheath. The outer sheath is required to cover all parts of the cable and works as an outer cover, outer jacket, outer jacket. The outer sheath would be made of extruded black FRLS PVC compound, fire redundant smoke PVC compound, type ST1 for control cable and ST2 for power cables, or it could be made of polyethylene PE material, right? So this is all is the cable constructions parts. So accordingly to the applications, we have to select which part we will take and which part will not take, right? I hope I'm clear on that. And when like we write the cable specifications, in few cases we also write the cable constructions coding. So below is the like coding practice we use. It could vary, but generally this practice, as per the Indian Standard IE 7098 Part 2, this practice is they have recommended. So if you are taking the aluminum conductor, then coding we have to use as A. If in case there is aluminum cable, so this coding is when we take the cable, so what we do, we cannot cut and we cannot see all the cable internal components. So the cable manufacturer have to do the embossing, marking on each 1 meter length of the cables on the outer side. So this, when they do the marking, so they use the coding, and this coding comes based on the cable constructions. So if the inner side is aluminum, then in the coding A will come. If copper, then no, nothing will come. No, C could be used, but generally no, nothing. They do not use anything because in the cable there is only two options: aluminum or conductor. If not aluminum, it means that would be copper only, right? If aluminum, then A. Then aluminum A. Then after the core or conductor, there would be like the major part they cover here. All the major components of they cover in order for the cable coating. Next is the cable inner insulations. So if we are using the XLPE, then 2x. If we are using the PVC, then white we take. So A 2x means aluminum conductor XLPE inner insulations. Round steel wire. This is about the armoring, and flat steel strip armor. So if it is round wire armoring, then W will come. And if it is flat armoring, then F will come. And we have discussed where we go with the wire and where we go with the flat, right? If cable diameter inside or up to armoring is up to 13 millimeter, then we go with the wire. And above 13 meter, we go with the flat. If double round steel wire armor, then WW. Steel strip armor, then this is for the aluminum, right? Aluminum. If steel ammunition, in that case, WWFF. If non-magnetic, it is not for the aluminum. Aluminum is here, like in case of it is double flat, double round wire, then WW means both. This is for the steel as well. This is also for the steel. And it is for single layer, it is for the double layer. And if non-magnetic aluminum round wire, then instead of W, we have to use WA. And in case of aluminum flat strip, in place of F, we have to use FA. And then we indicate the outer sheath, which is generally we take PVC, and that represented by the Y. So like AWXY or AX, A2XWY, A2XFY. This is the like designation for the cable constructions. Then they mention about the type of the core, like whether 3-core or single core cable, and size of the core or conductors, and then manufacturing year, when they are manufactured, year, and make of the cables. So this all uh, embossing or marking done on the cables. I have taken a cable drum photo. So if you see in the cable drum photo, this is cable. So if you see on here, and regular each 1 meter interval cable marking has been done. So I've taken a very close look here. So like if you see here, Grand Lake cables, electric is the manufacturer of the cables. 1.20 kV, it is LT cable. XLP insulations, this cable is manufactured as per the IS 7098 part 1, 3.5 core, 10 square mm. A, what is this? A2X FY.
A means aluminium, 2X means the XLP, F means flat.
Armored, and
Yeah, and Y means the outer PVC.
Outer PVC insulation. And then here they have some manufacturing number there. Right.
Yes, sir.
This is standard for all cable sets manufacturer, or
Yeah.
there will be different?
Yes. Generally, this practice followed. Usually, this practice followed things. So now what we discuss so far in the cable, what we should know about the cable constructions as a design engineer. Then we should know about the cable constructions, and based on the constructions, we do the selection, right? We also parallelly cover the selections as well. Isn't it? We discussed about each component selections, what component we have to take, construction and selections, and then we have to do we should know about the cable selections. Then after that, we should know about the cable sizing calculations. And once cable sizing calculation, then we have to purchase the cable, and then we have to prepare the cable data sheet, or we have to review the cable data sheet. So that also covered in the constructions and selection of the cables. And then we have to prepare the cable installations drawing, whether cable to be installed underground or above ground. And if it is underground, so what is the method? If it is overground, so what is the method? And when we are putting the cable into the substations, at that cables we use the cable dedicated tray or trench we use. So when trench passes through the road, then we use the hume pipe in order to pass the cables. So we should know about the hume pipe quantity calculations. There are so many things about the installations that we will discuss. Sizing calculations also will discuss. So is it okay to continue, or we can keep the part in the the remaining part in the next class? A lot of things need to be discussed. This is all about the cable installations. This is the trench that we use in the cable inside the switch yard. Trench. This how cable enter into the trench. So we do the hole, then we take the PVC pipe through that we enter the trench. Cables enter into the trench. And then if cable crossing, trench road crossing, then we use the hume pipe that looks like this. So now we have to do, so this is the how we represent into the drawing, and this is how we do at the site. So now cable trench coming, now road crossing. So this trench converted into the hume pipe here. So now we should know how to calculate. This is a section of the trench. So we should know about the pipe quantity calculation, that how much pipe required to cross the cable through the road. Right, cable bending radius, then we will enter into the sizing calculations and all this stuff about the sizing calculations. A lot of things about the sizing calculations, then voltage drop, right? A lot of things to be discussed. Is it possible that if we keep some extra class during the weekdays, is it okay?
Yes,
Yes,
Yes, sir. Okay, sir.
Okay, sir.
At least 1 hour, up to
Yes, sir.
2 days in a week. Okay.
Yes,
So
sir. Enough, sir.
we will have the class some class. I'm trying to keep it tomorrow as well. So in a lighter mode, note down we will have a class tomorrow, but I will reconfirm you tomorrow in the afternoon.
Yes, sir. No issue, sir.
Because I have some other work as well. So if I get the time, I will take class 9 to 10 or 9 to 10:30 like that.
Okay, sir.
Okay.
Raghav sir, I have some doubt actually.
Yeah.
Yeah, actually, you told me that cable charging current will be mentioned in the cable specification. There is 1.3 times like that. Is there any limit for the charging current? How we can able to accept it while doing the document?
It would be better if we can check through the cable standards. In that there should be any value about the charging current. I will check, Rajkumar. There might be some value in the specifications as well. The
Yeah,
IC
okay.
as well.
Yeah, that's fine. For reviewing and approving that, we should know something actually, the limit or something like that. And one more thing, sir. For the class party sim, you told me actually above 65 volt, we have to install the SPL. So how to ensure that this much distance the voltage will be induced? Also, we have to
We do the
install the
measurement.
SPL.
We do the measurement.
Measurement is that we cannot able to measure. So the cable is through, it will be completely the metal sheet will be covered now, including the outer sheet.
No, at the time of
So
the installation, it is not covered.
uh,
I don't think there would be some
is there any test or something like that we do? Or
like
the
that.
cable
Yeah, like
data
that.
we have to take
Yeah,
it
like
from the
that
cable
only.
data.
Yes, like that. Some test we do.
That if it is possible, something you could test and translate it and something. Whether from the cable technical data sheet we can take it, or we have to do some test for measuring the device where we have to install the SPL. Because number of the SPL also according to the route length we have to install in that
Yeah.
case.
There would be some. I'll check, Rajkumar, if any uh, reference document find I will share with you. But there would be some testing for sure.
Okay. What will be the problem, sir, if we are running the both end SPL? That only the voltage will be induced voltage will be there. Right? That is the only thing. No? If it is one end is Sheath and another end is we install the SPL, means the open circuit voltage will be there, right?
Yes, voltage would be there.
If both end SPL is installed, is there anywhere that was used like that?
Like both end SPL installing. So what could be the issue? The issue would be the induced voltage. That would be the
And I just want to know where we have to use that single end earth, double end earth,
single earth.
one.
Double earth we do not use. We discussed, Rajkumar. Double earth we
Okay, yeah, that okay.
Yeah.
Because of circulating current, we are not using that.
Yes.
Okay.
So
And single end earth and with the SPL,
so we
without
use
SPL.
we use the single earthing, single point earthing, and we use the cross like single and cross joint earthing, and our single point earthing we do, right? So, and
Okay.
when in the single point earthing, your generally we do up to 2 kilometer.
Up to 2 kilometer.
Yeah,
Okay.
up to 2 kilometer we are doing single point.
That means a transformer to GAS or transformer to switching area.
Yes, in the local substations. And
Okay.
when the voltage, when the length increasing, then for the
For
extra.
this administration to station, you are telling.
Yeah.
Length increase. Okay.
Yes.
Okay, sir. Fine, thank
you. Raghav, sir.
Yeah, sir.
Hello. Sir, long back, I have been to a diagram for this cable layout. I saw this cross bonding to the location where the cable ends. Means two cable are joined together. At that point only, we generally used to use SVL and cross bonding. Is that means?
Yes.
That is joint
just
B.
at the joint base.
Yeah, I also heard like that only during the in the location of the joint bay only we insert a link box actually. But here it's as per above 65 old it is that we have to install the SQL that is a remote for me actually.
So this cross bonding can be done only at the cable joints.
Normally it will be like that, sir. If it is underground cable, it will be all will be covered, all will be it will be backfilled. So wherever the joint is there, that it will be there will be a joint bay, will be accessible like that. The provision will be there actually.
That would be
As
easy
of
to
my
do.
knowledge.
Yeah, that would be convenient to do there at the joint point. Yes.
But how can we be sure that at that point only that 65 voltage, induced voltage is more than 65? It can be less.
That's the only thing, sir. It was confusing. Sir only told actually he will check it if something is there. We can able to confirm.
Yes, sir. Yes, sir.
Sir, we are using that non-linear resistance in SVL, right? So is there any specific value for that resistor, or we need to
Yeah, we
calculate?
calculate. Yes, we calculate. There is certain formula so that we can calculate the SPL. Yes.
Okay, so shall we cover in next?
See,
Okay.
Chirag, what I wanted to cover. I don't
Okay,
have
okay,
any
sir.
issue in that. The only issue is the timing.
Okay, sir.
I want to cover each and everything.
Okay, sir. Okay, sir. Thank you.
But the issue comes around the timing. If time allow, I will try to cover. Okay, and there is one standard. I will IEEE 575, which there is one dedicated standard for this. Like skipping the name, there is one dedicated standard for the cable. IEEE 575, missing the name. I'll arrange this standard so that if anything that I could not.
So you check it at your free time actually. It's already around something.
Sorry, come again.
You can check it at free time and you can share it during this class.
There is one standard as well. IEEE 575 somewhere. I'm missing the name. Standard. So that I will provide it, and you can go through. Which is very good standard for the cable bonding, earthing, grounding. I'm missing the name. Like that. Anyway, I'll arrange it.
Okay.
Okay. Any other query? Any other?
Sir, you covered the Sheath voltage
keep the same
calculation, sir.
time. I will do the 9 p.m. Vishal, don't worry.
Sir. Hello, sir.
Yeah.
Sir, you covered the Sheath voltage calculation. Yeah. Any document available, sir? So you kindly share the only, sir, not cover timing issue. Okay, sir, but you share any documents available.
I will see.
Okay, so okay, sir, no issue.
I was looking
Okay,
for the document. I could not find in my computer. But, I will arrange and I will send. Not worry.
Okay, sir.
If I data bank anywhere, I can find.
Okay, sir. Okay, sir. No issue, sir. Yeah.
Yeah, it's fine. Anyone have any query? If no, so we can wind up the today class.
Okay, sir. Good night, sir.
Good night, sir.
Okay. Thank you all. Thank you.
Okay, sir. Good night. Good night.
Good night, sir.